You did both of them. Yes. Right, right. When you multiply it all out, you shouldn't have any I's in your answer. Anything else? Okay, so I told y'all wrong about I. If it's okay, so like number 9 is 2, 3, and I. Oh. Then I would need to do x minus 2, x minus 3, x minus I. In order to get that I to cancel out, I'm also going to have to do x plus I. Because here's why. Technically, it's 0 plus I or 0 minus I, so you'd also include the conjugate on that one also. You have to do it for all of the imaginary ones too. So that was the one, number 9 was the only one that had that imaginary in it, so you'll want to do it. You'll want to do the plus or the minus on that one. That's my bad. I'm sorry. I just flubbed this lesson up from start to finish. And I realized as I was in third block, I did good in third block. Third block was great. But anyway, then you'd multiply that out. But yes, you shouldn't have any I's in your polynomial answer. Yes, the conjugate. Yeah. Oh yeah, you do. You need me to finish working it? To be x squared. You didn't do what? So there's the first one, and the second one would be minus I squared, which would be I squared plus. I mean, x squared plus 1 and multiply it. Anything else about your homework? I am sorry about that. Oh, Adam. All right, well, let's talk about today. So yesterday we wrote the factors given the zeros. Today we're going to find the zeros given a factor or two, or maybe no factors because we might have the PRZ. I know. Y'all don't seem so excited. As we factor polynomials, remember things like synthetic division to find other factors, division, PRZs that will allow us possible zeros there. And we're going to use these techniques so that we find even the complex zeros. So this is just a continuation of yesterday, y'all, because I didn't get through everything, obviously. I'm sorry. Let's say I gave you and I said to write it in linear factorization. What does that mean? Does anybody know what linear factorization means? It's factored out, but you can't have any exponents on your x's. So I can't, just because it's not factorable a certain way, I can't leave it like that. I have to have it in x plus a 0, or you know, every 0 is a factor. Remember we talked about that little theorem yesterday? So x minus that value. So even if it's an imaginary, I want to write it in linear factorization. So the first thing to do this, bless you, I'm going to start by finding a 0. How might I find a 0 of this? PRZs. I do not know. X to the 5th minus 3x to the 4th minus 5x cubed. I do not know a 0 right off the top of my head, and I'm assuming that you do not either. What? 7. What are the PRZs here? 1, 2, 4, and 8. Well, the leading coefficient is 1. So no, I would divide all of those by the factors of 1, which is still itself. Yeah. So let's start testing some. I'll start with 1. One, 1, -2, -2, -7, -7, -2, -2, oh look, that one worked. You'll see why this is different than what we've been doing in just a second. So tell me so far, what does this look like factored down? X minus 1 times x to the 4th minus 2x, y'all are not with it today, minus, minus 8. Do you know how to factor that? PRZs again. That comes from this one. Okay, so it's the exact same PRZs, but I'm going to try something different. And I would graph this to try to find a place where there's a 0 so I know kind of where to start. And so if you look at the graph, it looks like it might be crossing at -2. So let's check. 1, -2, -7, -2, and -8. So, because I'm trying to get it to where I can factor it is the goal here. All right, so -2, -4, 8, 1, -2, -4, 8. And I knew that was going to work because I know what the graph looks like. I saw it crossing at that point. So now I know, no, not really cheating. Because this is not, the goal here is not that you know how to PRZ and get it down this way. We're going to get to the complex 0 part, which is the new for you. This was what you were tested on the last test. X to the 3rd minus 4x squared plus x minus 4. Can you factor that? Yeah. Yes, I can finally get that to where I can factor. How, Adam, can I factor that? Split it. This definitely groups. So here I'm just going to bring down my 2 linear factors here. How do you know those are linear factors, by the way? It's just x plus a number, x minus a number. There's no, it could have a coefficient, but it can't have an exponent to be linear. Huh? I could look at it and tell, I can tell that if I take an x squared out of these two, I'll be left with x minus 4, which is what I have right here. So if I take that x squared out here, it leaves me with x minus 4. First sign, can't take anything out, so I'm going to take out a 1. X minus 4. This took me a while to get to this point, but I'm finally here where I have factored completely. Yep. Okay, so that's not it, because what did I ask you to do to start with? Linear factorization. So I started by finding a 0, and then I factored completely, but the problem is, when I'm factored completely, I'll give you a second to copy that and then I'll go. Yeah. What is the problem with my factored completely policy? This is not linear, and I need to make it linear. Any ideas what I can do? Say it again. That's if it was x squared minus 1, but that's a good idea. Can't. Okay, you're close. Say it again. There are imaginary solutions here. So here's what I'm going to do. I'm going to find the actual zeros of this factor. Okay. In other words, the first one I know is crossing at 1. It's crossing at -2. It's crossing at 4. Do we all agree there? What are the zeros for this factor, though? What's the square root of -1? I. So do you agree with this? There are 2 zeros. What did that theorem say yesterday that we talked about if you have a 0? How do you write the factor given a 0? X minus the 0, right? So now, after I find the zeros, then I'm going to split this factor using those 2 zeros. So I've still got these real ones, but this is going to be exactly. This is x minus I. This is x plus I. So these are 2 different equations here. This would be what we call factoring with real coefficients. Okay, I would have to leave it at the point that it's completely factored, but with the imaginary, so I don't want to include imaginary solutions when I talk about real coefficients. But this is what we would call factored with, yep, this is linear factorization. See the difference in the two? Okay. If I started with the linear factorization and I wanted to write it with real coefficients, then what would I need to do? Exactly. I would need to multiply these 2 out, because remember, they're always conjugates of each other. I would need to multiply those 2 out to end up back here. Does that make sense? Okay. Yes. Yep. I have something else to show you. We're going to kind of piggyback on that. I'm going to ask you two things here. First thing I'm going to ask you is, what are the other zeros? And then I want to know, what is the linear factorization? Now this time I've kind of got a springboard here. I've got a starting zero. But oh dear Lord, the starting zero is complex. Still a zero though, so do the theorems still hold true? Yeah, they do. They do. If I have a zero to start with, how do I find the other factors of the other zeros? I could do that, and I could do long division to get there. That would work. What else could you do? You're definitely on the right track too with the conjugate thinking. Here, I know, the first thing I know is looking at this is, if 1 minus 2i is a 0, that means 1 plus 2i is also a 0. Do we agree? So Abby had a good idea, and that's a perfectly fine way to start it if you want to start that way. If you want to multiply those two together and get that real coefficient factor and divide it, we would have to use long division though, right? Yep. What else could we do? Remember, this is saying that x minus this is a factor and x minus this is a factor. Can you divide by a 0 to get the other factors? Think back over here. This was a 0. We put it on the outside to get the rest of the factor. Could you do that over here, even though it's complex? We could. Well, but that's not a 0 anymore once you FOIL it. You see what I'm saying? Because then you'd have an x squared. I'm talking about doing synthetic division. I'm talking about, could I do, this is the 0. 4, 17, 14, and 65. Could I do that? Y'all are looking like, oh my gosh, what are you doing? Okay. I could do the opposite. I could do this one or the opposite. Because it's always minus, right? It was negative in here. Let's see what happens. 4 multiply around 1 minus 2i times 4 is 4 minus 2i. And now add. Oh, sorry. A placeholder for what? Yep. Brett, you made me mess up again. I'm so sorry. Y'all need some of those erasable pens like I have. 4, 0, 17. I was so excited about doing this synthetic division because this one's not going to work. I'm going to have to do the conjugate with it. Okay. 4 minus 8i. Now add. Oh my goodness, what's going to happen? FOIL. So what's happening here, and I'm going to stop right here because if you get to this point, you can go, but wait. While that's a 0, I can't factor anything that's got coefficients that look like this, right? Not yet, you can't. So I'm going to stop right here and say, let me try the conjugate instead. What is the conjugate? Four, 0, 17, 14, and 65. So let's try it this time. No. Yes.